Hello viewers, in this presentation we discuss about Base Theorem of Probability. Before going to discuss about Base Theorem, we should know about independent event, dependent event and conditional probability. Independent event. Two or more events are said to be independent if the happening and non-happening of any one of them does not affect the happening of others. For example, in tossing a coin 2 times, the happening of either head or tail of the first tossing does not affect or is not affected by the happening of either head or tail of the second tossing. Therefore, outcomes of first tossing and outcomes of second tossings are independent, or event of first tossing and events of second tossing are independent event because they are not affected by each other or they are not influenced by each other. And otherwise, events are said to be dependent. Now, we explain the Bayes theorem with an example. Let a bag contains 5 black balls and 3 red balls, or 3 red balls plus 5 black balls is equal to 8 balls. A bag contains 8 balls, out of which 5 are black and 3 are red balls. Let us draw 2 balls one after another without replacement. Now, what is the probability that both are black balls? Suppose A is the event that the drawing of first ball is black and B is the event that the drawing of second ball is black. Therefore, probability of A is equal to, so that is the probability of drawing black ball from this box where we have 5 black balls. So probability of drawing a black ball is 5 divided by total number of balls, that is 8 balls. Now, after drawing one black balls, then the bag will contain 4 black balls and 3 red balls. So, the bag will contain 3 plus 4 is equal to 7 balls, where 3 balls are red and 4 balls are black. That means, after drawing the first ball, if it is a black ball and if it is not replaced, then the bag will contain 3 red balls and 4 black balls. So therefore, probability of drawing the second ball, that is second black ball, that is B, given that the first ball is already drawn, that is A, is equal to, so in second drawing we have 4 black balls out of 7 balls. Here, probability of B, given that given that A is occurred is equal to 4 by 7. So probability of B is called a conditional probability of B given that probability of A. This is called conditional probability of B given that A already has occurred, and that is equal to 4 by 7. Here we have got the conditional probability of A given that A is equal to 4 by 7. See, here the probability of B is affected by the happening of A. So that is why it is called the conditional probability, or we say it conditional probability of B given that already A has occurred. Here P of A or probability of A, it is the unconditional probability, but P of B is a conditional probability because the effect of happening of A is appears in case of happening of B. Here we have to find out the probability that both are black balls. Therefore, we have to find out probability of A intersection B, A and B, and that is equal to probability of A given multiplied by probability of B given that A, and that is equal to 5 by 8 multiplied by 4 by 7, and that is equal to, after cancelling this 8 by 4 we get 2, so we get 5 by 7 to the 14. Now here we have got the probability of happening of A and B is equal to 5 by 4. From this relation we get probability of B given that A is equal to probability of A and B by probability of A. So conditional probability of B given that A is equal to probability of A intersection B divided by probability of A. Now from this idea of conditional probability we may derive the Base theorem. Here this implies probability of A intersection B is equal to probability of P of B given that A into P of A. Similarly, probability of A given that B is equal to probability B intersection A divided by probability of B, and this implies P B intersection A is equal to probability of A given that B into probability of B. Since P A intersection B is equal to P B intersection A, both are same, therefore P B by A dot P A is equal to P A by B dot P B. So this implies probability of B given that A is equal to P A given that B dot PB by PA, or that is equal to PB PA given that B by PA. So this is actually the Base Theorem. See, Base Theorem states if P B given that A is equal to PB multiplied by P of A given that B divided by P of A, where P of B by A is called the posterior probability, P of B is called the a priori probability, and P of A given that B is called the likelihood probability, and P of A is called the marginal probability. In general, P of Bi given that A is equal to P of Bi P of A given that Bi divided by probability of A, where I goes from 1 to n. Here Pi is nothing but summation Pbi into P A given that Bi. I goes from 1 to n. Here Pa is nothing but summation I goes from 1 to n of product of P of Bi and P of A given that Bi. And that is equal to probability of Bi intersection A divided by summation I goes from 1 to n P of Bi intersection A. So this is the Base Theorem. Now let us take an example where by using the Base Theorem we can solve a problem. Example: a bag A contains 3 white and 2 red balls, and a bag B contains 4 white and 3 red balls. One ball is drawn at random from one of the bags and is found to be red. Find the probability that it is drawn from bag B. Again, a bag A contains 3 white and 2 red balls, and a bag B contains 4 white and 3 red balls. One ball is drawn at random from one of the bags and is found to be red. Find the probability that it is drawn from bag B. Solution: let E1 be the event that the ball is drawn from bag A, E2 be the event that it is drawn from bag B, and let E be the event that the ball drawn is red. Since we have 2 bags, and out of these 2 bags we have to select one, so that is why probability of E1 is equal to probability of E2 is equal to half. Since we have to select either A or B, So that is why probability of E1 is equal to probability of E2 is equal to half, that is 50%. That is out of E1 and E2 we have to select, or that is out of A and B we have to select 1. So that is why it is the probability of E1 and probability of E2 is 1 by 2. Since the ball drawn is found to be red, we have to find the probability that it is drawn from bag B, or we have to calculate probability of E2 given that E. Now, the probability that the ball drawn is red, if it is drawn from bag A, then probability of E given that E1 is equal to 2 by 5, because bag A contains 2 red balls and 3 white balls. So total 5 balls. So out of these 5 balls, we have 2 red balls. So probability of getting or drawing a red ball is 2 by 5. So P of E given that E1 is equal to 2 by 5. And the probability that the ball drawn is red, if it is drawn from bag B, then P of E given that E2 is equal to 3 by 7, because bag B contains 4 white and 3 red balls. We have total 7 balls. So out of 7 we have 3 red balls. So probability of getting or drawing red ball is 3 by 7. Therefore, P of E given that E2 is equal to 3 by 7. Hence, by Base theorem we have P of E2 given that E is equal to product of P of E2 and P of E given that E2 divided by P of E1 into P of E given that E1 plus P of E2 into P of E given that E2. So that is equal to P of E2 is half multiplied by P of E given that E2 is equal to 3 by 7. P of E1 is equal to half into P of E given that E1 is equal to 2 by 5 plus P of E2 is 1 by 2. P of E given that E2 is 3 by 7. So we have got 1 by 2 multiplied by 3 by 7. We take common 1 by 2 here, 2 by 5 plus 3 by 7. So cancelling numerator half and denominator half, we get in numerator 3 by 7, in denominator LCM is 35. LCM is 35. So we got 35 by 5 is 7, 7 2 is 14, plus 35 by 7 is 5, 5 3 is 15. So that is equal to 3 by 7 is equal to 29 by 35. And that is equal to 3 by 7 into 35 by 29. So we cancel this 35 by 7, we get the 5. So ultimately the required probability is 15 by 29, and that is equal to, that is nothing but P of E2 given that E. So this is how we can solve this statistical problem with the help of Base theorem. Thank you.